So if you want to find the line that's tangent to a curve at a given point, you need two factors, you need two pieces of information. The first one is the point. So you're given t0 equals pi over 2, so that means your point is r of pi over 2. So that is 4 plus the cosine of pi over 2. Pi over 2 is 90. Cosine of 90 is 0. 19 plus the sine of 16 pi over 2, so it's 16 times that. And 3 pi over 2 is the z-coordinate. So for us, that will be a 4, comma. What is the sine of 16 pi over 2? 16 pi over 2 is 8 pi. Remember that 2 pi is one full turn around the unit circle. It's 360. So that means you go around the unit circle 4 times, and you end up where you started. So the sine is the same as the sine of 0, which is 0. So that's just a 19, and then 3 pi over 2. So that is the point where my line starts, where it goes through. To find the tangent vector, which is the other piece of information I need, I just need to find the derivative first. So that will be minus sine t, comma, 16 cosine t, cosine 16t. You don't change the angle when you derive. So the 16 comes out. The derivative of sine is cosine, and you keep the angle. That's the chain rule. And then the derivative of 3t is 3. So when you plug in after you've derived, you don't have to simplify anything. Before you plug values in, you can already plug in t equals pi over 2 to see what you get. That will be negative sine pi over 2. We know what that is. 16 cosine 16 pi over 2, comma 3. Same arguments we had before. The sine of 90 equal to 0. The cosine of 8 pi is the cosine of 0. So that's 1. So it's 16 times 1, which is 16. And that is the tangent vector. So the line goes through this point with tangent vector this. So the equation will actually be 4 plus 0t, 19, 16t, and 3 pi over 2 plus 3t. You can clearly see that when t equals to 0, maybe I should get rid of that 0 there. Simplify as far as possible. For t equals to 0, I clearly find that point, which is the point I was supposed to have. And as t progresses, I'm adding multiples of this vector, which is the tangent vector. So that's exactly the tangent line I was looking for.